Bismillahirrahmanirrahim. Today we are going to discuss about what are the carbohydrates and their major types. Okay, and among those types, we'll discuss today only one type. Okay, well, what are the carbohydrates and what is their structure? Today, our topic of discussion is what structure of carbohydrates. Okay, structure of carbohydrates. So before discussing the structure of carbohydrates, we should know what are the carbohydrates. Okay, carbohydrates are the polyhydroxy aldehydes or ketones. These are polyhydroxy aldehydes or ketone. Should I define the carbohydrates first? Carbohydrates are definition is what these are These are the polyhydroxy aldehydes are ketones. Polyhydroxy aldehydes are ketones. Look, what is a polyhydroxy? What is a polyhydroxy compound? Should I tell you people first so that you understand why do we call these, why it is necessary that these should be number one, polyhydroxy. Number two, either they should be aldehydes, these should be necessarily polyhydroxy, number one, and either aldehyde or ketones. Now, suppose here is a molecule, it is polyhydroxy. Okay, look, this is polyhydroxy, but it is neither ketone nor aldehyde, it is polyhydroxy. Okay, it is neither ketone nor aldehyde, so it doesn't qualify to be a carbohydrate. Here is other molecule. Look, this is suppose a molecule which is say ketone. Okay, it is ketone, but it is not a carbohydrate. Okay, it is ketone. This is polyhydroxy. I would like to tell you people another molecule. Suppose here is a molecule which is this is say aldehyde. Now this is aldehyde. Okay. Suppose I would like to increase the number of carbons. This is an aldehyde. It is not a carbohydrate. It is not a carbohydrate. Okay, this is not a carbohydrate. It is polyhydroxy. It is aldehyde. These are not the carbohydrates. Okay, so what is a carbohydrate? A molecule, an organic compound which is polyhydroxy and either aldehyde or ketone. Okay, now let us find an example of a carbohydrate. Look, this is a polyhydroxy. I would like to draw again this very molecule. Look, 1, 2, 3. Okay, it is now polyhydroxy. Here is a carbonyl carbon. Here is hydrogen. Okay, now it is polyhydroxy and its structure is what? Aldehyde. So an aldehyde and being polyhydroxy, it is a carbohydrate. Okay, number one. I would like to draw another formula, another molecule. Look, okay. Here you can see what? This is the carbonyl carbon. Here is the carbonyl carbon. Okay, and it is polyhydroxy. Okay, a polyhydroxy aldehyde or a ketone is known as what? Carbohydrate. So you should have gone through an advertisement for what the from the marriage bureau. They say what uh, a, an engineer or a doctor is required from such and such caste. Okay, suppose that caste is A. Now, suppose an engineer appears as a candidate for the marriage. He is asked either you are belonging to the A caste. He says no. He would be rejected. On the other hand, there is a doctor. There is a doctor. He belongs to caste B. He would again be rejected. There is yet another person. A young man comes and he says that I belong to what, the caste A. He's asked either you belong to if you belong to caste A, okay, either you are doctor or engineer. He says no. He would again be rejected. Okay, so it is necessary that the groom who is going to become the groom for a beautiful girl, he should belong to caste A, number one, and either he should belong to caste A, and the second qualification is what? Either he should be doctor or engineer. Okay, either doctor or engineer. He would sorry sorry he would qualify to be a groom. So here, but a carbohydrate should belong to caste A. it should be polyhydroxy, and either it should be engineer or the doctor. So it should either be what, aldehyde or what, ketone. I'm telling you people that any compound which has carbonyl carbon bonded on one side with the hydrogen and at the other side with the carbon is known as what? Aldehyde. Yet another, having carbonyl carbon on both sides, the carbons is known as what? Ketone. Okay. So a ketone must be necessarily polyhydroxy, or an aldehyde must be polyhydroxy necessarily, and a polyhydroxy should either be ketone or an aldehyde. I think this should be now clear. What is a carbohydrate? Okay, now let's come to the structure of carbohydrates. Look, structural structural types of carbohydrates. You can say, in other words, the classification of carbohydrates. Okay, carbohydrates are classified as what? Three major types. One is what? Monosaccharides. The second is what? Oligosaccharides. And the third is what? Polysaccharides. You can make the notice of it that the saccharide, the word saccharide is the part of monosaccharide. Saccharide, saccharide, and saccharide. Saccharide means what? It has been derived from, this word has been derived from what? Saccharin, which means what? Sugar, which means what? Sweet. Okay? Now, let's come to monosaccharides. Monosaccharides means what? Having one sugar. Mono means one. Saccharides, sugar. Okay? Now, these are also known as what? Simple sugars. If these are hydrolyzed, they don't remain the sugars. On the other hand, if you hydrolyze the oligosaccharides, they yet remain the sugars. They furnish monosaccharides. If you hydrolyze polysaccharides, they furnish many sugars. Okay. I think it should be now clear that the carbohydrates, these are classified into three major types: monosaccharides, oligosaccharides, and polysaccharides. Okay. Now here is what the further classification of what further classification of the monosaccharides. Classification of now we are going to start with what the classification of monosaccharides. The monosaccharides are classified as what? Trioses, tetroses, pentoses, hexoses, haptoses, and octoses, etc. Okay. If they have three carbon, these are known as what? Trioses. If they have four carbon, these are known as what? Tetroses. If they have five carbon, they are known as what? Pentoses. If they have six carbons, they are known as what? Hexoses. If they have seven carbon, they are known as what? Haptoses. If they have eight carbons, they are known as what? Octoses. If they have nine carbons, they are known as what? Nonoses. Okay. Now, let's see the structure of what trioses. Here is an aldehyde form of what? Trioses. Okay. And here is what the further classification of what tetroses. This is, you see what? Aldehyde form. These are four carbons. Okay. Here are again four carbons. Look, if both the hydroxyl groups are on the right side towards what? The oxygen. Okay, this is known as what? The cis. This is known as cis side of the molecule. This is known as trans side of the molecule. Okay, if both are present on the cis form, it is what? Erythrose. If here is what? Hydrogen, and if this is, here is hydrogen, and here is what? Hydroxyl group. You can see the change over here. I think now it is clear. This is what? Triose. This is what? Triose. And this is what? Erythrose. Okay. Now let us come to the pentoses. I have drawn here the structure of pentoses. You can see this is carbonyl carbon. This is carbon number 1. Look, carbon number 1. This is 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. I think you should have made the notice of it that the numbering of carbons starts from carbon and carbon. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now you see, this is what ribose. 1, 2, 3, 4, 5. 3. Here should be what? Suppose this is 6. Okay. If this is 6, then this is not pentose. So we should come here. This is what? The last carbon. This is what? 5th carbon. And this structure is what? This is the structural formula of what? Ribose. Okay. Now look. Hydroxyl group, hydroxyl group, hydroxyl group, hydroxyl group. All the hydroxyl groups are present on the cis form. Okay. This is ribose. Go on to the next. Here is what? 1, 2, 3, 4, 5. Look at the second carbon. At the second carbon, hydroxyl group is towards the trans side. This is what? Arabinose. What we call it? What? Arabinose. Now the next one. This is known as what? Xylose. What we call it? Xylose. Look. This is its hydrogen. This is what? Xylose. Look at the difference. Here is what? The first carbon is, carbonyl carbon. 1, 2, 3, 4, 5. At the third carbon, the hydroxyl group is towards the trans side. Here in arabinose, the second one, at the second carbon, the hydroxyl group is on the trans side. And last one, xylose. You can see this is carbonyl carbon. Okay. And here is hydrogen. And here should be again hydrogen. And here is what? This is hydroxyl group. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, and 5. If the second and the third, if the second and the third carbon have the hydroxyl group on the trans side, then it's known as what? Xylose. All these molecules are produced by nature for you, human beings, for the animals, for bacteria, for fungi, for life. Okay. Now let us come to see an example of the hexoses. I think you have understood what the structure of triosis, tetrosis, pentosis. Now let's come to the structure of at least one example of hexosis. Hexosis. Look, 1, 2, 3, 4, 5, 6. Usually, the students, they think that this structure should be that of what glucose, but it is not glucose. It is the isomer of glucose, structural isomer of glucose. Let us have the numbering of this molecule: 1, 2, 3, 4, 5, 6. Okay, again, I would like to remind you people that the numbering of these molecules, aldehydes and ketones, you should have stated in the last semester that the numbering starts from the carbonyl carbon. Okay, well, here is another 1, 2, 3, 4, 5, 6. You can make the notice of it that hydroxyl group at the carbon number 2, that is on the trans side. Okay, the opposite side of what? Opposite side of oxygen. This is what? Allose. This is what? Altrose. Okay, this is not glucose. Neither this is glucose, nor this is glucose. Now let me tell you people, let me show you people another molecule. Now look, let us have the numbering of this molecule: 1, 2, 3, 4, 5, and 6. Make notice of that. Hydroxyl group at the carbon number 3 is on what? The trans side. This is what? Glucose. Okay. If this hydroxyl group were on this side, the molecule should have not been glucose. That should have been what? Mannose. So let me tell you people the other isomers. This is allose, altrose, glucose, and here are the allose. I will tell you people what? Allose, altrose, glucose, mannose, and glucose, galactose, idose, and talose. Okay, just by changing the position of hydroxyl group, the molecule is changed. You can count 1, 2, 3, 4, 5, 6, 7, 8. So glucose has seven brothers. Seven brothers. Okay. And the eighth brother is what? Glucose itself. Okay. So hexoses in the aldehyde form are produced by nature in different organisms in different forms. That very glucose which you have been studying since your lower class is glucose, which is formed as a result of what? Photosynthetic process in plants, that has seven brothers, seven isomers. Okay. And the keto form of hexoses is what? Fructose. Okay, fructose. So this is all about the definition and the structural types of carbohydrates. If you have understood it, if you like it, I would like to request you people to subscribe my channel, Biologyteacher. Thank you very much.